All right, we are getting started. First piece is a quick review from when I was gone, as well as there's questions like this on today's assignment, whoever was asking. Do we need to know it? Yes. All right, x to the 2/3 equals 19. It's important when you're solving on the test to recognize where your x is. Is the x a base or is the x an exponent? Where is the x in this problem? The base. When it's a base, you're not going to do the log of both sides. You are going to do something to both sides, and it's raise both sides to what power? To the reciprocal, 3/2. I'm going to pause here and have everyone quickly take out their calculators or come up and grab one, because you do need to know how to plug this in on test day. All right, we're ready? Now, typically, guys, we would think of it as the square root of 19 cubed, but is 19 a perfect square? No. You can type it in that way. You can type in square root 19 and then cube it, but you do have the possibilities of typing it in exactly like you see it. So turn your calculators on, clear them. 19, your exponent is right here, right above your catty corner to your 7. It's right there. It's a caret key. Do you see it? Looks like a little rooftop key. Raised to the, and I'm going to clear mine, and I'm just going to change my mode to classic because that's typically where we work. 19 raised to the, and what was the fraction? I'm going to use my fraction key. You can use your division key. 3 fraction 2. Fraction key is right here. I'm not sure how it works if you use your division key, if it would work. I'm in the different mode.
I like this one. Oh yeah, I got the same thing. I use the division key.
Yeah. Okay. Yes. Okay, can I see how you typed it in? Can you bring it up here so I can see how you typed it in? Did you use division key or fraction key? Division. Okay, then if you're going to use division, you'll need parentheses around your 3/2, or just use your fraction key, which might be easier. Okay, so she's saying it didn't work on hers using the division key. It may have worked for you because you were in the different mode. So get comfortable with the mode, get comfortable with how to plug it in. 82.819. Do we agree?
Yeah, that's it.
All right, that's it. 82.819. Did you use parentheses or fraction key? Okay.
Are we doing a 3 spaces?
Yes, three spaces. All right, number 2. 2.32 equals log x minus 12.7 all over 1.5. All right, is x an exponent or part of a log? Okay, so what am I going to try to isolate right now? The log of x. All right, so usual things that you would typically do in other equations, what would you multiply both sides by? 1.5. Can you guys go ahead and plug that in your calculator right now? 2.32 times 1.5. And what do we get? 3.48 equals log of x minus 12.7. What would the next step be? Add your 12.7. Go ahead and do that now. But you're not going to use your log button. I'll show you what we're going to do. What did you get when you added these two together? 16.18 equals log of x. All right, let's pretend this decimal was really long and you don't want to write it all on your paper and you reduced it or rounded. That's okay if you do that on your paper, but should you leave the decimal in your calculator as long as you can? Yes. Right now it's not that big of a decimal, but typically if it is, leave it in your calculator as long as you can. All right, log of x. Who knows how to solve it from here? How do I? All right, good. I can't ever divide by log unless I'm dividing by a whole log of a number. But log by itself, I can't ever just get rid of. All right, just like I can't multiply by log unless it's log of a number. All right, say again what you said a little louder.
Don't you do the, like we already know the base is 10, so you do 10 to the 16
Equals x. Good job. She is correct. So know when you're raising both sides to a reciprocal power, know when you're doing the wraparound, and when you are taking logs of both sides, because there's a lot of different things going on for this test. All right, that's a number you can plug in your calculator, 10 exponent key 16.18. And if it comes out crazy like a E number, I think it does, we're going to leave it like this. Huh?
Do we not put like log?
You don't put log, because once you do the wraparound, what happens to the log? It's gone. You're rewriting logarithmic form to, what is this form called? Exponential. You're changing logarithmic to exponential. You get, it gives you like a crazy scientific notation number, right?
Yeah.
So let's leave it like this. All right, questions? Okay, number 3. 2/3 raised to the x equals 7. All right, we've had x in 3 different places. As a base, part of a log, and now where is the x? And as an exponent. Who remembers what we do to both sides? This was in the video notes on Wednesday. X-root it. We can't x-root it, unfortunately, or we can't raise to the 1 over x power.
Can't you multiply it?
Reverse it. I can't flip the base. I cannot divide by the reciprocal. Rewrite it.
Yeah, like
Okay, guys, this is not the way I showed you in notes, but it is a method you can use. Rewrite it in logarithmic form. Would you like me to do it that way or the way I showed you in notes? Both ways work beautifully. They're the same. If you do it changing to logarithmic form, you're going to use change of base formula eventually. The way we did in notes is we took the log of both sides so that we can bring the exponent down to the front.
Oh yeah, I answered that question.
What, both sides. So you do. So let me show you what I'm talking about. You would do this: log of 2/3 to the x equals log of 7. Are you multiplying both sides by log or taking the log of both sides? Taking the log. All right, and the whole reason we do this is to do what with the x? Move it to the front, so it's no longer an exponent. X times log of 2/3 equals log of 7. Now that I'm solving for x, now can I divide by the log? Now can I divide by the log because it's log of 2/3. Do you see that? It's log of 2/3. I can't over here just divide by a log by itself, but I can divide by a log.
You can divide a log into a log. Is that what you mean?
Let me show you what I'm talking about. I cannot reduce the logs here. Logs don't cross out. Nor if these two numbers were reducible, had a common factor, I cannot reduce. You can add them, you can subtract them, but you can plug this in your calculator to divide them, but do the log pieces reduce or cross out?
No.
No, same thing over here. When I had log of x, I couldn't divide by just the log, because log by itself is just like a square root by itself. You need a number. All right, crosses out, x equals, plug that in your calculator. Do not forget to close your parentheses before you hit divide. Do you need help plugging it in, or you've got it?
No, I got it.
Is it positive or negative? Negative 4.799.
So if there's only one log, you can't divide it.
Correct.
So that's okay.
You can't divide by log, but you can divide by log of 7 or log of
So you
2/3.
can't do that because it's just log of x.
Right here. Right. If it was 16, well, you could divide by log of x, but remember we never divide by x.
Oh, so if it was like log of like 5, you could
Then, and if there was, say it was log of 5, and it was multiplied by something else, then you could divide by log of 5.
but you can't multiply it if it was just log, or divide it if it was just log.
Right. You can't divide or multiply by just log by itself. It has to be log
Oh, it has to be
of
with something.
with
Oh, I see.
something.
That makes
Log
sense.
of
Right. It's like saying multiply by the square root of what? It needs to have more to it. Yes.
Okay, why did it come out negative?
Well, like, why did your calculator, or why in general?
In general.
Log of 7, this one is asking us 10 to what power is 7? And the bottom one's asking us 10 to what power is 2/3? So one of these comes out to be negative. This probably comes out to be a fraction, 10 to what power is 7. But 2/3 is smaller than 1, so it's going to come out to be a negative exponent. So it's this bottom one here that's making it negative. This one's making a decimal. That one's making it a negative decimal. All right. Would you like me to show you, Trinity, the way you said to rewrite it?
No.
You're good? Okay. It's your choice. You guys, it's up to you. All right. Number 4. E to the negative 3x plus 1 equals 7. All right. Look, assess, figure out where is your variable. A base, part of a log, or an exponent? When it is an exponent, what are you going to take of both sides? The log. In this, typically I use log base what? 10. And I said why in notes. We use log base 10 because of?
Because the calculator.
Because of the calculator. Calculators are programmed with log base 10. But they're also programmed with log base E. So if I have a base that's E, am I going to use log base 10 or log base E?
Log base E.
And when I use log, I'm going to actually write it for now. Log base E of e to the negative 3x plus 1 equals
Whoa, it's a lot of E.
log base E of 7. Now, typically I don't write log base E. What's another way to write this? ln. ln of e to the negative 3x plus 1 equals ln of 7. Is ln of a 7 a decimal in my calculator waiting to come out? Okay. Now I'm going to pause here. What's the whole reason we do this? To get what with, do what with the exponent? Put it to the front. Now that's a bigger piece this time, but it's all coming to the front. So negative 3x plus 1, I'm going to put in parentheses, ln E equals ln of 7. Do you guys see what happened? This purple piece here came to the front. That's the negative 3x plus 1. And when it comes to the front, what's left is ln of E. Does anybody remember what ln of E is?
Isn't it 1?
It's 1. Log of 10 is 1. Log base 5 of 5 is 1. Log base E of E, which is...
So if it's a log of itself, it's 1.
Yes. If the base and that and ln is base E, so if those two are the same, it is 1. All right, so negative 3x plus 1 equals ln of 7. I'm going to let you guys do this one on your own. Now, when you're plugging things in your calculator, don't ever round until the end. So leave the numbers in and go. What are you going to plug in first? ln of?
7.
And then what are you going to do to that? Subtract the 1, and then after that, you're going to divide by
Minus 3.
negative 3. You're right. So ln 7 minus 1 divide by negative 3. Don't forget to close your parentheses at the end of your ln. So where am I at? ln 7, close parentheses, minus 1. I'm going to hit equals before I hit divide. Equals, and then divide by what? Negative 3.
This is done. Yeah. So you get how to do that. Is that all right? I don't know how they work.
You don't know how, what do you
I
mean?
don't get like how they work, but I know how to do it.
You know how to work them, but
Yeah,
you
I don't
don't
get
quite have a
how.
grasp of why it's working that way.
It's mathematics.
All right, it's not. X equals negative 0 point what? 315. All right. One more like this, and then we're going to get on to the word problems. Number 5, y equals negative 73.5 ln parentheses 1 minus x over 90. All right. Where is the x? A base, part of a log, or an exponent?
It's a base, right? It's part of it.
Part of a log. Here's the base. Here's part of a log, and here's the exponent. Is it more like 1, 2, or 3?
Or 2.
It's more like 2. Do you agree? Lauren told us on number 2 what to eventually do, and once we got the log by itself, what did we do? We rewrote it in exponential form, right? We did the wraparound. All right, so you need to keep track. When x is a base, raise both sides to the reciprocal. When it's part of a log, you're eventually going to rewrite it in exponential form doing the wraparound. When x is an exponent, you're going to take the log or ln of both sides. So since this is like number 5, what am I going to try to isolate or get by itself? This big log, this big ln. So I should have wrote up here because I don't know if it's throwing anybody off that there's what in there? A y. All right, so let me write it up here. Solve for x in terms of y. And yes, that will be on the test. Solve for x in terms of y. That just means get x by itself like you would on any other problem. It's just your answer is going to have a y. Bless you. So what do I divide both sides by? Now typically, what would I do if y was a constant? What would I do here? Plug it in the calculator, right, and get a decimal. But I can't, so I'm going to leave it as y over negative 73.5 equals ln of 1 minus x over 90. This answer is going to come out looking really wonky because we can't plug the numbers in our calculator, but we need to know how it works. All right, questions on anything I've done so far? Did I get the log by itself like I wanted to? All right, so what's the base here that I don't see? E? So I'm going to do e raised to that equals that. We're rewriting in exponential form. E raised to what power? I'm going to move that negative up. You don't have to. Negative y over 73.5 equals 1 minus x over 90. Once I change from logarithmic form to exponential form, otherwise known as the wraparound, once I do that, is the log still there?
No.
No, that's why we're changing from logarithmic form to exponential form. The log is gone. So when I do this wraparound, the ln is gone. Same thing that happened over here. When I did the wraparound, the log is gone.
So the base or whatever becomes like that number, and then just the part on the
Other side,
is just there.
exponent, and then whatever you're doing the log of is the answer.
Oh, that's pretty cool.
All right? So exponential form, changing from logarithmic to exponential, your log is gone. All right, I want to solve for x, so what can I subtract from both sides? Or what should I subtract? Minus 1. Now, is that minus 1 going to become part of the exponent?
No.
It's not. It's e to the negative y over 73.5 minus 1 equals what? Good job. Negative x over 90. And we're almost done. I want to get x by itself, so what can I multiply both sides by? Good job. Negative 90. And after you do that, you don't have to distribute. I can't plug it in my calculator, so if you leave it just like this as your answer, that's beautiful, that's fine, and I'm happy. Negative 90, parentheses, e raised to the negative y over. All right, ask me your question. You were with me. Okay. All right, yes, it's on the test. No.
That's it?
Like, is there more is what she means. No, that is it.
Why is it not positive? Because you have to divide by the negatives.
Yeah, negative 1.
Because you're not distributing.
I'm sorry. I didn't distribute. You can. I said you can. You don't have to. It's up to you.
That's all you.
If you did, you would have negative 90 e to the negative y over 73.5 plus 90. You don't feel like we're distributing?
That's
Yes.
all you,
I thought we could have negative exponents.
You when you're rewriting it, it's okay if you do. If it bothers you, then you can rewrite it as negative 90 over e to the y over.
I think we're gonna stick with the first one.
Yeah, it's up to you. All right. Okay, questions? We're good? All right, word problems. I don't know.
That scares me.
Word problems. It's, I'm not going to have time to do the second lesson, so it's going to be worksheet 6 in your packet. Yeah, and you have your packet, right? Yeah. All right, the actual word problems, and you can get the notes online. All right, compound interest.
Oh, interest. I know how to do that.
Compound interest formula.
I remember this.
A equals P parentheses 1 plus R over N close parentheses raised to the n t. Did you guys do this last year?
No, it was the easier version. Like
A equals
I remember that this is 6th grade. Yeah, before
yeah.
A equals
before math.
P times E raised to the RT, sometimes called the PERT formula.
Oh, of course, a perk. Oh yeah.
Yeah, I don't remember it being this hard.
All right.
Pertinent fact.
Now, a few things. These two formulas will be given to you on the test.
Wait, are they the same?
No. I'm going to explain the difference. Okay. This one is compounded monthly, yearly, daily, quarterly. This one's compounded continuously. This is the one you'd rather
This one's
have.
like infinite.
This is compounded like every second of every day. It's just compounding continuously.
Kind of thing.
All right. So, listening. You will need to know when to use each one. You will need to know what each letter stands for. So we're going to write that down now. Are you ready? All right. P. In our the half-life formulas I did in notes, P's are the same spot that A naught was in. Do you remember what the A naught was?
No, what are you talking about?
I said A naught in notes. I know I did.
Here. I wasn't. Not.
Okay, thank you. It is your initial amount.
So,
And it's not always A naught. Like, for example, here it's P. Whatever's being multiplied here, not the A, whatever's on the right side, whatever's on the other side of the
it's like
A or
your-
whatever
your
letter it
starting-
is,
Your starting money.
your starting money, the amount you take to the bank. All right, R stands first. It's exactly what R, like, starts with an R. What is it? Rate.
The rate of
T is time. And N is the number of times
It's a time thing.
compounded. Number of times compounded.
It's like the. Wait, what was that?
Compound interest. So it's compounded monthly. It would be 12.
So it's. So it's out of a year.
It's, yes.
So if it
Yes.
was like a year, then it'd be a 1.
Compounded yearly would be 1.
And if it's every day, it's 366.
Yes.
366 of them. Well, that should be a trick question. Oh, on a leap year, how much? And it's compounded.
All right. Now, why does this one over here not have an N? Can anybody tell me why this one over here does not?
It's infinite.
Because it's compounded continuously. All right. So, A is the only letter I haven't done. What is A?
Answer.
The answer, you're right. So the amount, he's right. The answer, it's
Gotta get one of those right.
it's the amount after time T. It's the amount you have after 5 years, after 6 years. Whatever the time is, this is the amount you have after that given amount of time. All right, number 1, $1,000 is invested. Yes.
You get one thing right.
What was that?
So bad.
PE and P the same thing.
Oh, P is P. P, these two P's are the same. E, this is P times E. E is the number in your calculator.
Oh, what?
Sorry.
Wait,
Yeah.
say that again?
This, she said, is PE the same as P. P is P. Those two P's are the initial amount. It's the initial amount times all of this. The initial amount times E raised to the RT, where E is a number in your calculator.
Isn't it like 2.72?
718, yeah.
Wait, how do you get the E?
It's above your ln key, so you would hit
And
shift,
then you just
plug in your exponent, yeah. All right, $1,000 invested
I gotta sit.
at 12%.
That's not
Compounded quarterly. Period. How long will it take to reach $22,500? Figure out first which formula you're going to use. How long is this class?
the black one, right? So
Yes.
it's the continuous one. It's rate of interest.
Where are you at? Oh,
And
okay.
how much times compounded is it?
Oh, I didn't know if you were roundabout.
So it's the A, E, E, R, T. Pretty sure it's
It's
continuous, yeah.
compounded four times quarterly, buddy.
Where?
I was thinking about you. Hold on a second. Okay, what formula would you use, first or second?
Is it compounded
Okay.
four times in the time also?
Yes, so why is it the first one? Because it's compounded quarterly. This one's compounded continuously. You might want to put a little note here, compounded continuously. So you know, those are the words you're looking for. Plug in as much as you can here. How long will it take? What are you looking for?
The times.
The time. So
Oh,
time
wait,
is
so
your
we don't
unknown.
have time.
Time is what you're looking for.
I was like, I don't.
Hello?
Oh, but we have the answer.
What is it?
No, I mean, like, we have, that's four, right? Yeah.
Oh, okay. Is that where you were at before, right?
I'm on the drawings here, right?
Yeah.
What is the initial amount?
P is 1,000.
Yeah.
Haven't done that in a while.
One
Can I call you back?
plus,
Oh, jeez.
oh, R over N.
Okay. So I will.
Wait, 4% R over N.
And thank you for checking.
What's N?
I will.
At least
I will.
4.
Okay. Bye-bye.
I'm on the drawing, but I don't
NT.
Oh.
Remember to-
All right, do you guys get it?
Wait, I'm almost there.
Okay.
Same thing. I told you before.
P, what's the initial amount? 1,000.
N times T.
R, what's the rate as a decimal? 0.12. T, how much time, or is that what we're looking for? N, how many times is it compounded? Quarterly means 4 times a year. A is the amount after the given time. What is the amount after given time? 2,500. All right, let's get this going quickly. A, I'm just going to rewrite the formula. P parentheses 1 plus R over N raised to the NT. All right, yes. Quarterly means 4 times a year. Not, yeah? No, not 1/4. Okay. We're ready? Okay, so what do I plug in for A? What do I plug in for P? 1 plus R is 0.12 over 4 raised to the N, which is 4, and then T. Do you guys agree? Okay, where is your exponent? Your exponent is T. Where is it at in the problem? And I'm saying it wrong. Your variable. What is your variable? T. Where is your variable? And I gave you the answer when I asked the question. It's in the exponent. Sorry, guys. All right. Which means I'm going to try to get this by itself. What do I divide by 1,000? I'm going to do 2 things. Divide by 1,000, and I'd like you to plug this in your calculator. I would plug it in 0.12 divided by 4 equals and then plus 1. Plug this in your calculator.
It's 1.03.
1.03. Thank you. And then this 25 divided by 10 is 2.5
Yeah.
equals, and you said that's 1.03 raised to the 4t. All right, we did these in the review section. What do you do when your variable, Austin, get your head up off the desk. What do you do when your variable is an exponent? You take the something, you don't wrap around. You do that when it's a log. You take the log of both sides, and there's no e here, so I'm going to do log of 2.5 equals log of 1.03 raised to the 4t. And the whole reason we do this is to what? Bring this to the front. Log of 2.5 equals 4t log of 1.03. Now remember, log of 1.03 and log of 2.5 are decimals hiding in the calculator. What do I divide both sides by? Log of 1.03. Now remember, I can divide as long as I'm dividing by log of something, not just log by itself. All right. 4t, can you guys plug that in your calculator? Is it a long decimal?
Yeah.
I'm just going to put dot, dot, dot here. You don't even have to write it down, but what are you going to do to both sides? So leave that long number in your calculator and divide by 4. And then round to 3 decimal places.
7.75, but
0.
is that the answer? Because you have like a percentage of the quarter.
7.75 years. Yeah.
What? Oh, it's not quarters.
You're looking for time.
Yeah. Oh, yeah.
Is it always going to be in years?
Yes, unless stated otherwise. All right. Are we ready? No? Number 2. If $25,000 is invested, what? Oh. Is invested at 8.5% interest, compounded continuously. Is that right there, keyword for which one you're going to use? First or second?
Second.
Second, the PERT. How long does it take for the investment to quadruple? In value. All right. This goes back to what I shared with you in video notes on Wednesday when we talked about half-life. Do you guys remember that? Okay. I'm going to write stuff down. We know we're using the PERT, A equals P raised to the RT. P is the initial amount. How much do we have? Well, this one we don't have to worry about like we did in notes. It's actually a little bit easier. What's the initial amount?
100,000. Oh, no, I'm sorry.
25,000, 1, 2, 3. R is as a decimal point. Move it over 2 places. 0.085. Time, we know what we're looking for. And A, what's the amount after, we want it to what? Quadruple, so what's 25,000 times, times 4, 100,000? All right. 1, 2, 3, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5 equals 25,000. E raised to the R, which is 0.085 T. All right, where is my variable? Make sure I say it right this time.
It's in the
Exponent. When it's an exponent, what do we take of both sides?
log.
The log. So what are we going to do first? What do we divide by? What do you think it's going to come out to be when I divide? Should it come out to be 4? Because if we're quadrupling, 4 equals, and that reduces to 1, which you do not have to write, but you can. 0.085t. At this point, are we ready to take the log of both sides?
Yeah.
But it's not log in this case. What are we going to do? ln of 4 equals ln of e raised to the 0.085t. And what happens with the...
Isn't ln of e equals 1? So 1 would it be?
So before we change this to 1, what do we do with this? Move it to the front, which is the whole reason we do this ln of both sides, is to get that out of the exponent.
And ln of e is just 1.
And then ln of e is just 1, so I can ignore that.
So then how do you divide
A, quadruple in value, so we took the 25,000 and times 4. Nick gave it to me, yeah. Okay, so divide both sides by what? 0.085. 0.085. Don't forget to close your parentheses on your 4. ln 4, close parentheses.
Do the ln of 4 first, or no?
Yes, so ln 4, close parentheses, divide 0.085. ln 4, close parentheses. All right, what do we have? 309. All right, I'm going to get as much done of the next one as I can because I know the bell's going to ring very soon. Guys, what one worksheet are you doing today? 6. What initial investment is needed to reach a goal of $500,000 if the investment, you guys are writing this down with me, if the investment is at 11% compounded continuously. Is that a key word right there? For a total of 20 years. All right, let's at least plug things in and talk about how to solve it. Is it the PERT problem?
Yeah.
All right, what is the initial investment? A is how much we end with. How much do we want to end with? 500,000? Is that right? Oh, sorry, guys. What else? P, do we know what P is? Is that what we're looking for?
That's what we're looking for.
What is the rate as a decimal? And T, so when you plug it in, you have 500,000.
One more zero.
Thank you. P, we don't know. E raised to the 0.11 times 20. Did I plug that in correctly? Yes or no? All right. P, is P part of anything special, or is it just kind of by itself? So is this a decimal in our calculator? It is. What are we going to divide both sides by? Before I plug it in, I'm going to divide by E raised to the 0.11 times 20. I'll put parentheses there. E raised to the 0.11 times 20. Just at least know how to plug that in your calculator. I'm going to give you the answers, so if you plug it in later, you know if you plugged it in correctly. 55,401.58. $55,401.58. Know how to plug it in, because you do need to know that for the test. Did you get it?
I got it. I was off by a couple cents.
Okay, good.
Yeah.